Hi, everyone. I'm Casey Uhlenhout. I'm a product manager at Databricks. And now we're going to talk to three of some of our most valued customers at Databricks about their use cases in generative AI. All right. Thank you all so much for joining us. We really appreciate you all taking the time to share your experiences, building like what you're building with GenAI and sort of like the challenges and the benefits that you've seen from working with GenAI today. So maybe before we get started, can you all like briefly introduce yourself? So name, company you work for, your title, and kind of what you're responsible for at your organization. And then we'll kind of dive thick into, hey, what are you building with GenAI and go from there. So maybe Vijay, can we start with you?
All right. Hey, my name is Vijay Sankaran. I'm from State Street. It's one of the world's largest financial services firm with interests in custody banking or and asset ownership and management. We also have interests in the area of investment management with one of the largest operations dealing with, and it's one of the earliest providers of ETFs, as you might have heard of them. And in our space, we have a bunch of interaction with generative AI solutions, specifically because we end up with dealing with a lot of documents in our world, and these are financial statements and transaction documents, and we also have a lot of need for a number of different research. Data-based research needs across the company.
Shamir, can we go to you next?
Yeah, absolutely. I'm Shamir Mirza. I'm the Senior Director of Data, AI, and Machine Learning and R&D. So I lead both the data platform and the innovation groups. And I work for 7-Eleven, which is the world's largest convenience retailer.
Awesome. And then Lindsay?
Lindsay Maiko. I'm the head of data science for Providence Healthcare, a large West Coast-based not-for-profit healthcare system, 50 plus hospitals, tens of millions of patient visits. I'm in the IT department, so I have platform responsibility to support the enterprise. We have a federated model with data science and AI. I also build full stack vertical solutions, which I'm really excited to talk about today.
Awesome. All right. So a lot of our customers at Databricks are trying to figure out, hey, what should they build with generative AI? And then how do they get ROI out of these use cases? And so Vijay, when we spoke earlier, you had mentioned, hey, there's sort of like three ways to get value from generative AI. So like, hey, you can either get productivity gains, you can build a net new product, or you can have customer improvements that you're launching. So kind of like loved that framing. So maybe given that, can you like walk us through one of the use cases that you have at State Street? That's one of your most like strategic generative AI use cases that you all are building there.
Definitely, thank you. So the along those three dimensions or axes that we typically measure all our products that we try to build out. Let me start with the customer delight or customer experience improvement kind of things, right? A lot of these millions of trades that flow through our systems over the every single day tend to have a lot of human touch required. And whenever that happens, we end up with having to. It's not just customer support in the traditional sense. In many of these cases, it is simply tracking and actually canceling a trade that was issued by an automated system. So in all those scenarios, we end up having to conduct research on where is it in the overall trade clearance workflow and halt it there. So one of the new things that we are innovating on is the instruction comes to us in forms of documents. The data for our transactions is already in large systems, including mainframes, which we end up having to have copies of and data lake oriented structures. Right. So we're building out a full-fledged platform that is going to do smart research in terms of locating where in the workflow it is, and then specifying also, okay, what needs to happen next in terms of, and the latest innovation that came out just about last week from OpenAI with their Strawberry model, which allows us to think in several steps. That's essentially what we were building out, but that's definitely upending a little bit of our work, or probably accelerating some of our work in that space.
Got it. And so what is the business value that you're delivering with this sort of like document-centric automation that you're building?
There are three, again, it clicks on all three of our axes. Like first is the customer delight, which is what used to take approximately 2 to 3 hours in some cases, is now being, the time scale is being compressed. So the customer is able to get what they want much faster, right? That also translates into productivity gains at our end, which is this whole notion of having lesser touch on our employees from our employees. And then, of course, the new product introduction, we haven't yet gone in that direction fully, but there's a lot of thinking going on about how to present this as an offering to our customers as well.
Awesome. And then Shamir, can you kind of walk us through at 7-Eleven, what are kind of the use cases that you are seeing the most excitement around in your org, and how does that align with like what you all are doing on the bleeding edge versus, hey, where is actually the most value being delivered?
Absolutely, yeah. So we've done a lot of really cool things at the bleeding edge in terms of personalized search and all these other things that we're piloting and trying out. But really where we've seen the most excitement is simple data answering bots. So we've trained LLMs, but what we find is just using the out-of-the-box models, especially the existing Genie API with data rooms has been a super effective method with a consolidated data set for people to be able to ask questions and receive answers that are meaningful. And so we're currently working on exposing that through the most commonly used platform for communication at our organization, which is Teams, because people aren't logging in to Databricks to do this. Typically, they're pinging an analyst on Teams to say, hey, what did sales look like for the Southwest region at this time compared with the previous year, right? So being able to just ping a Teams bot rather than hunt through, find the analyst, and hope you get the right answer has been very exciting for the business.
And is there something about 7-Eleven in particular that makes it so that your business owners and stuff need to like better understand what's going on in like their area, or what's kind of like the value that people are really getting being able to like talk to their business data or their like retail data?
Yeah, the biggest thing really is that we have just about 14,000 locations in the US alone. And we do something called Retailer Initiative. We're hyper localized and we really care about how our stores are performing based on the local markets, right? If you go to 7-Eleven, we want you to know the cashier, we want you to know the assortment, and it's unique to your region. So we are focused on really understanding how each store is uniquely operating and how each region's uniquely operating. So sometimes discovering those insights at a very micro geographical level is very important to each of our area leaders who are looking at that data. So we haven't gotten to the point yet where we've exposed these bots to those leaders yet. We're in the process of letting the executives look through them and interact with them. But the next step naturally is to allow field-facing individuals to leverage this data more naturally. Today, they just rely entirely on Power BI reports.
I see. Yeah. I've heard that sushi in the Japanese 7-Elevens is like the best in the world. So makes sense about the hyperlocality. Also, and then Lindsay, I think you have sort of dived more into the like, hey, how can we use GenAI to build new products? So can you kind of walk us through what you're doing at Providence Health with generative AI and kind of what's like the most strategic use case that you all are working on there?
Yeah, and for context, the portfolio is pretty big, but I'm going to tell you about, I think, the most interesting, the one that I like the most, and I think that when all things shake out, might have the biggest impact. So the use case starts with our Institute for Human Caring, led by a palliative care doctor. Doctors, clinicians give about 15 minutes of training to deliver end-of-life news to families and patients. The actual conversation takes 20 minutes to an hour. So you can tell that's not enough training. It's bad for patients. It's bad for the physicians. And so for some years, we've had a program to train people on how to have these difficult conversations. The problem is we have tens of thousands of clinicians, caregivers, as we call them. So we just could never scale. Like we were hiring actors, or we would pull clinical staff off the front line and have them play the role. They would be their coach. We could just never train everyone the way we needed to. And recently, based on some really fascinating and emerging research that shows that humans seem to really like the way AI communicates around like medical issues. Like we find AI empathic, which is a little bit surprising. We started to build an AI-based training and communication coaching platform where people could learn and practice these difficult conversation skills for the core initial use case of palliative care conversations. And part of what I love about it is that, well, so we have a working, beta or first version. It's in testing. People are starting to use it. There's tons of feedback. And what we quickly saw is that large language models don't behave the way humans do in these conversations. We fine-tune them to be very pleasing, to be verbose, to communicate like everything all at once. And so we actually have to unwind some of that. And so the cognitive architecture that we've developed is highly agentic, has dynamic prompts that update as you flow through the graph of the conversation, and requires RAG to be inserted at specific rates. The value is obvious for palliative care. It's like saving money in actors. It's also making us better people. But you can imagine there's a lot of other things you have to train workers on. Difficult performance conversations, diversity and inclusion, diversity pronouns. There's a wide list of use cases that provide that just like for automation, as well as upskilling, as well as like the mission-driven work that we care the most about.
Right. Yeah, because that's like it's like not just augmenting people, but it's also like helping make them better themselves.
Yeah, that's what I love about it. I mean, we do need to save money. Healthcare is money losing situation for not-for-profit, but so that matters. But like the core is to be better.
Awesome. Okay, so that's super helpful because a lot of people have no idea like what's the spectrum of Gen AI use cases that people are doing. So I think that was like an awesome variety of like RAG, agentic architectures and stuff. So now we're going to kind of dive in to that specifically, where what we found at Databricks is many of our customers are really struggling to get to quality. Like getting quality Gen AI apps into production is hard. And so many of our customers are finding ways to sort of embrace data intelligence. So by using their enterprise data to improve general intelligence to achieve quality, or they're using compound AI systems. So rather than shipping like one monolithic model with like maybe like a huge prompt on it, you're actually breaking it down into like modularized components where you can like specialize each component. So can each of you kind of like walk through how you're either using data intelligence or like a compound AI system to improve the quality of the applications you all just walked through? So we can start with Lindsay maybe, because we just ended with you. So we can start on you kind of like alluded to already. You're kind of building a multi-agentic solution, and then we'll kind of like.
And it's timely because this is the thing we're talking about a lot on my team, and just generally, I think when GenAI launches, it's so easy to prototype something in ChatGPT with one prompt, right? You just think if you can tinker with your prompt a little bit more, like
Right.
you get to the outcome you want. A key lesson for me is that that's an evolutionary dead end. Don't tinker with prompts endlessly. Think like comprehensively design the system and like the sequence of events that need to happen to deliver value. I usually think of that as a graph. So I encourage folks.
And is this because you find modifying the prompt becomes too unwieldy or is like too unpredictable? Or what's led you to like move from that to system thinking?
That I've just seen in one, that you can get such wild swings in behavior by changing one word in a large prompt. Like as an example, in the empathy use case, when we said, you are a patient, 45 years old with knee pain named Lindsay, like that generated like very unrealistic behavior. When we said, you are a professional patient named Lindsay, just inserted that one word, suddenly they started talking in a way that made a lot more sense, because professional patient is a term of art that you'll find in like Reddit or something like that. And like that unpredictability and that kind of like variance, right? As you're kind of basically like kind of pointing the attention heads at something else so wildly, like I don't like the trial and error bit of that.
Yeah.
Also, practically, I found that like, I'm a leader. I want everything fast and I want it like awesome. And so I found that my teams were too slow. Like they would just get in this cycle where like, oh, it's not quite there. Let's tinker and then let's come back next week. And you get in this cycle. And so we were doing AI engineering in a kind of like kind of free-form way rather than doing it in the way we would do software engineering or data engineering, where you have specific criteria at each step of the way. They're testable, like you know when you're done, and then you move on. And you can also apply other like prompt development frameworks like DSPY or something like that.
Right.
Kind of treat the development in the normal way we build software.
Yeah, real quick. So Shamir and Vijay, I saw you nodding at when Lindsay was talking about the prompts being tricky to manage. Is there like quick anecdotes or like similar challenges that you all have had there they want to share real quick, and then we'll dive deeper into Lindsay's multi-agentic architecture?
Yeah, I mean, for us, especially with user questions related to sales or other data, we wanted to give a real, very valid answer. And so having an LLM perform non-deterministically is a risk that I'm often not willing to take when it's related to either store performance data or financial data or any query anyone has. So we've been using embedding models to route rather than agentic flows. We're starting to look into agentic flows as a way to do this effectively as well. But as of now, we're using embeddings. And I can share some of the architecture diagrams to show you where we're at today and where we're trying to go.
And for us, it's the prompt engineering, as I think Lindsay might have been hinting at, leads us to a dark path because the document, in our case, even if we keep the prompts the same, the variety that we face in the documents that are coming towards us from the market, actually the data demographic changes. And as a result, the response changes. And so we start looking at a different part of our operation just because in the document structure was different or the words used in the document were different than what the whole solution was set up to do. So what we end up doing is a lot of like pre-processing the document, categorizing it, classifying it, using both older machine learning based and machine vision based techniques, as well as figuring out how to deal with RAG inaccuracies by using knowledge graphs in addition to the original RAG itself.
Okay, so then Lindsay, so I think what's kind of interesting about your case is you're like dynamically changing the prompt to like the patient agent, right? So you're like adapting it as the conversation goes on. So can you tell us a little bit about like how you architect and like what's like an example use case through that architecture?
So the fascinating piece of doing the design, and we just spent like an all day on site, is to design the AI architecture. We had to think cognitively. I'm a neuroscientist originally, so I was like, it was great to go back to the well. So we were talking about things like how do you express acknowledgement of someone's emotional state? How do you understand it? Like, it was like, that is not a thing that we would normally be talking about in a technology development session, but we had to discuss it, put it on a graph, and then define some quantitative criteria. So for this patient agent, they have a medical history. They have a demographic history, like age, gender, location. They have some permanent characteristics, like, they're very obstinate, they're very self-directed. And they have transient characteristics, like they're nervous, they're sad, they're talkative. And it's those transient characteristics that change through a conversation. I think that's intuitive to people. Like, you sit down with someone, as you become comfortable with them and they acknowledge your emotional state, you'll open up, you'll tell them things. Or if they're mean to you, you're going to start responding in different ways. So the transient psychological characteristics are what update as you flow through the conversation. And critically, that's where agents, like, kind of one of the places they step in is they're evaluating like the conversation on both sides, and they're looking to see where the doctor has expressed in a positive way, like an understanding of the patient's emotions, and then the trust can rise, and then the verbosity can increase. And so that's just on a mechanistic level, that's an updating of the system prompt. There's also an agent looking to coach the doctor that has access to the internal state. So it can stop the conversation and say, hey, this patient's getting really angry. They haven't told you yet, but inside the temperature's rising. You might want to rewind the conversation and try again.
Interesting. Wow, that's fascinating. And so how many agents are kind of contributing to this multi-agentic architecture that you built?
There's like 4 core phases of the conversation. So I think we have like 9 or 10 agents that are in, I like something like that, that we expect to interact.
Awesome. Yeah, because I think for a lot of people, they understand the concept of a compound AI system, but they don't really understand like what is it? Like what is exactly. So maybe Shamir, can you kind of like walk us through what the like compound AI system is that you all have built at 7-Eleven?
Yeah,
Uh,
I'll go through two things. I'll go through the first version. I have a document which may help follow along. So at a basic level, the first version of it that we built was user submits a query. We use a text embedding model and LangChain to do a loader basically with face. And essentially we make sure it's a valid query. Then we choose the LLM based on the text embedding model and we do the general processing, right? Where we're headed is more towards using an LLM node to do some of the selection of where to route things, whether vector store, Genie API, Confluence. We have a number of different tools we use.
so you
And
are going to use an LLM to do routing.
eventually is what we're attempting, because right now the embedding based model is working and we're happy with it. But long term, what we've seen is that as the complexity of our use cases grows, right, as we expand the number of data sets that we expose as data products, how do you ensure the routing is consistent in a way that there may be overlap between certain data sets, right? Like merchandising may look at sales a certain way versus how marketing looks at sales. So how do you make sure you route both sales queries correctly depending on the context? And so here we're doing a couple of different things with a document grader. Then based on relevance, an output generator, we validate that there aren't any hallucinations using an LLM node. And if there aren't, then we move on to the answer grader. And finally, whether it answers a question. So this is still a RAG-based approach with multiple agents throughout that process. But this is still early stages for us because as vanilla as this is, it works. And we've seen great success and users are happy with this. The reason we're looking at the future facing is because in many ways, LLMs, as you're seeing with O1 and others that are coming out, they're becoming more and more commoditized where you can have huge gains in performance simply by swapping out a newer LLM at some point. And so if they're able to process some of the ambiguity in a query and the routing portions of the query as a single interface routing, it'll solve a lot of the downstream issues we see with prompt chaining and setting up the right set of prompts.
I see. And the reason that you're going to like eventually move architectures is because you're expecting an improvement in quality, or what's sort of motivating
Yeah,
change in architecture?
so embeddings work really well when you have a very constrained search space. So if you know your users are always asking a very specific set of questions within a given data room, very powerful. As you expose more generalizable queries to the user set and then have it routed accordingly, that becomes more and more complex. So because we're exposing greater data products to the rest of our business with varying varieties of what the context may be, we're looking to make sure that we can handle the different types of users and queries that they may put in, right? An expert in finance will ask a question very differently than someone in the field. And so we want to ensure we don't drop in performance as the language being used changes.
Awesome. Wow, that was super helpful. Thank you for sharing that. Made compound systems definitely like super clear. And then maybe VJ, can you also walk us through what's sort of like are you all building a compound AI system or using data intelligence at State Street? Or how are you all architecting your solutions today?
Yeah, it's a mostly the data intelligence part, and I think I'll sort of try to connect to what Lindsay was mentioning earlier. In the agentic approach, where you have each of the agents is optimized for certain objective functions that they're looking at, right? When you have a cluster of those, they will sort of like collaborate to arrive at the solution. A compound AI system, unfortunately, tends to be very engineer centric in its thinking, right? It's a sort of a linear, if this, then that kind of a thing that we're all trained on trying to translate into software. So we are sort of like coming somewhere in between that in our compound AI solution, right? We end up with first of all, of course, RAG centric use cases. Then I was referring to the knowledge graph, which also rolls in some of the symbolic representation of our either it is workflows that have to solve a certain problem, or have the understanding of the domain understanding of certain types of securities versus whether it is like a derivative or a foreign exchange trade, there are different nuances in what happens in those areas. So at a high level, that's one thing. But for us, the bigger challenges were, as a very highly regulated industry, as a player in the industry, we end up having to demonstrate to our stakeholders, not only internal, but our regulatory stakeholders, that we have a responsible AI system, not just everybody can have a go at it at any LLM that's out there. So we're going about curating those LLMs, and we've come up with a sort of a much more deliberate approach to you might call it LLMOps, but essentially linking the LLM in the appropriate part of the overall solution. And when we make that call to the LLM, before that, or even while we are making the call to the LLM, we are not just a single LLM, multiple LLMs are involved. So we end up stitching these things together into a quilt work of functional calls, right? Function calls. And then that's what essentially is the overall structure of our solution.
I see. And do you have to track the series of calls for like audit purposes, or
Correct.
that's
we call as
that design, basically?
correct. So there is one is the responsible AI, and I'll probably just quickly show you one slide that tries to capture what it is that we are doing, which is in this notation, right? We have these. Of course, there are different applications. We just labeled them in the very broadest terms, but we are provisioning this API SDK, which essentially has all of these technical capabilities at the back end, the prompt catalog, RAG pipelines, and then prompt management, prompt security, and filtering. But essentially, what we have to provision is these kinds of things. You got your jailbreaks, input guardrails, output guardrails. All of these things are built into the overall architecture. Now we are looking to.
A lot of your compound AI system is applying a bunch of guardrails on there. Really kind of like Shamir also had like some guardrails added, like check if this answer actually answered the question, things like that.
Correct. And we also have evaluation pipelines, right? So that we have to keep track of whether the response that the LLM generated was satisfactory to the overall solutions context. And then, so then there's the other interesting thing I'd like to point out. I think this goes back to the first topic that you brought up. We're spending a bunch of time on this area, fine tuning, because unlike the prompt tuning, we're learning that the LLMs have not yet been trained on financial terminology. So a leg in the financial services world, especially when you're doing a derivatives trade, means something else than a body part. Right. So we end up having to train those kinds of things. So we're focusing on this, and this is where we're getting a lot of leverage out of Databricks' the Mosaic layer, right? We love that part as well.
Awesome. And Vijay, one of the things that you had mentioned before was as you moved into like generative AI, so a lot like your solution helps sort of like augment a lot of like the manual labor component and sort of like translating documents into like actual trades. But you said like, hey, back in the day, even though it was only maybe like 70% accurate, the 30% time it was inaccurate, you're able to like very easily figure out what went wrong. Whereas now it's like 95% accurate, but in that 5% of the time it goes wrong, you can't really debug. So can you kind of like walk through like what does it mean now that your problem space has shifted like that?
Thank you for that prompt. So the no pun intended, but the idea here is the pre-LLM world, right? We always had these deep CNN based neural network based techniques that with machine vision, where we could locate the coordinates on the page where you're extracting data from, and tie back the information that you extracted back to that thing, so that if there's something that goes wrong, you can, at least the humans in the loop can quickly triangulate to what could, no, I don't want it from this part of the page or this part of the document. I want it from this other place, right? And then there was also the feedback that they could provide to improve our models. Now, what has happened with traditional LLMs? They're only linguistic. That is, they can take in text strings. They're not visual yet. And again, that whole space is being upended by like the Pixtrals and the others that have multimodal LLMs, right? So the text-based LLMs lack that fidelity to tell us where you picked up this data from in the document, right? So so that gives a lot of trouble to our humans in the loop to repair the findings or the results of the solution. And that's exactly like you said it right. We were able to increase the accuracy of the information extracted, but we're not able to reduce the time to solve in its entirety.
Yep, makes sense.
If I may put it that way.
And then Lindsay, I think like the challenge that you were mentioning that you will run into is that off-the-shelf models are basically all tuned to be as pleasing and like nice as possible. And so like, why does that present a challenge for you and like what you're building with your patient AI and your conversational coaching?
I mean, so the dynamic prompting is like is a tactic towards that, be verbose, don't be verbose, right? And it needs to change based upon expected behavior at different parts of like the flow of the conversation. I think that you can also look at it from a different dimension and be like, this is an obvious fine-tuning problem. There's like two reasons why we're not taking that approach, although it makes total sense technically. One is that like we also are highly regulated and like we can't use technology till it GAs, and then there's still a long cycle of friction before we deploy. So we're super excited about Mosaic 2 and definitely want to use it and fine-tune open source models to be mean to us. We just don't have the approvals yet. But also like,
let's not make that our tagline though.
No, but what I love about it is like there are unintended there are unintended consequences to well-intended solutions. And there are use cases for which you need an LLM that is toxic. And those are weird, but like they do exist. And this is an example of it. The other reason is that we don't have a big training corpus. Like physicians know what these are supposed to feel like. We have like a vibe, right? But like we don't have like thousands of examples of like really good interactions or really bad interactions that we can fine tune against. And we absolutely can't pay doctors to sit there and read a bunch and score a bunch. And you can't outsource it to mechanical turk. So we had to some degree take the knowledge in a clinician's head and translate that into like some formal design, and then translate that into like features and stories that we could engineer against. One other thought I just wanted to share after hearing Vijay talk here is like LLMs provide a different path to value, whereas in previous machine learning, we had to be 95% accurate, 99% accurate. If you can automate 10% of a task, like only be right 10% of the time and like decrease the queue that humans do work 10% of the time, and you do that thing across 10,000 workers, that's huge. The ROI is monstrous. And so for those struggling to get value, things don't have to be perfect the way they used to. They can actually be pretty mediocre and still have huge value if you have the scale of a like large corporation.
Yeah. Shamir, any like challenges that you all are seeing come about as you embrace compound AI, or based on anything you've heard from like Lindsay or Vijay, anything that you want to add in?
Yeah, the thing I would add is reinforcing what Lindsay was saying is that time to value is actually surprisingly quick for a lot of low-hanging fruit. So, we've done a lot of simple things with troubleshooting manuals for our field technicians, where when they would have an issue with a particular system, they would have to go hunt through a bunch of documentation to find an answer. Now they just ask a question and they get the answer. So, it's not groundbreaking work or anything that we're doing. We're just taking the existing manual, passing it through an LLM, generating embeddings, and then returning answers. But it's yielded enormous lifts in terms of productivity and resolution of tickets. So for those who are hesitant to try stuff out, I think RAG in particular with embedding-based models are very simple ways to get into things to drive productivity. Don't hesitate there. Everyone will talk about the bleeding edge stuff, but the highest return on investment and value is the boring stuff with RAG.
Awesome. Well, thank you all so much. This was an awesome panel. We had like different industries represented, different use cases. So this was super helpful for everyone. So thank you all so much for sharing. And yeah, really appreciate you taking the time to be here. And we're excited for what you build next on Databricks. So thank you all.